Looking at this first problem, we know we shift horizontally. And another way to really look at this is we're going to solve what's inside, set it equal to 0 and solve, and that will tell us the direction. Because of this negative in the front, it kind of throws things off. So I do know that this is a horizontal shift, but which direction? A lot of times we're just going to cheat, or the way we do it so often is say we're going to go to the left 4, but we ignore that negative. So here's what really happens in the more mathematical way of doing this. Negative x plus 4 equals 0. If I move this over here, I get x equals 4. So that means it's a horizontal shift to the right 4 units. Let me give you a second example really quick. So y equals the square root of x plus 3. Again, going back to our shortcut method, which sometimes I think we use too often, and I'm just as guilty, is we say, oh, it goes the opposite direction, so it's a horizontal shift to the left 3. Well, here's why. X plus 3 equals 0. When I solve it, x equals negative 3, and negative 3 is in the left direction. So the last part here is I have a vertical shift up 5 units. To answer your second question, get something just a little bit different, but that looks like this. Here we know it's going to reflect the x-axis. Now, we're very similar. Let me give you a second example of y equals 1/2 x. Here we know this is a vertical stretch or shrink. And I think of it like this. If I take a fraction and smush it together, it's going to shrink and kind of go out the sides. So the shrink is going to be less than 1, whereas the stretch is going to be greater than or equal to 1 technically. Same thing is going to happen here, but when the fraction's on the inside is when it becomes the horizontal stretch. If what's on the inside, so if the fractional piece or the non-fractional piece is greater than 1, then it's going to be a stretch. If it's less than 1, it's going to be a shrink. Again, it's going to flatten when you squish it together.